So when you're animating stuff, sometimes it's good to be able to test things out quickly without having to deal with a lot of keyframes. And for this first video, we're going to look at how to set up the simplest driver possible without really having to do much math or anything. And to do that, again, I'm going to start with a very simple example. I'm just going to grab a plane, subdivide it a whole bunch of times. And we're going to go throw a displace modifier on here with a texture that we'd like to animate. Now, I'm just going to grab whatever texture. The first one here is fine. And I'm just setting up something simple so we can have something to look at while we're working. Maybe make this a little bit bigger. Here we go. And let's say we want to animate this texture. Now, obviously, if we want to animate this, we looked at this before, what we can do is we can create a helper object to help us with this. Set the texture coordinates to object and select that empty. Now, if I move this empty around, I'll be able to actually animate the texture and do all kinds of stuff with it. And let's say I just want to move it around, but let's see, we have, I think 300 keyframes here. There we go, or 300 frames rather. So I'm just going to play, but I don't want to actually use any keyframes for this, just in case I want to change the length of my animation and not have to deal with it. Now, the first thing I want to do is just have this move along the y-axis and have the texture move along the plane itself. So what we can do with our empty selected, we go over into item and we go into our y location. We can type hashtag frame. And basically what this will do is it will put the frame number in the value, use the frame number as the value basically. Now I'm going to set my scene to go from 1 to 300 here, just to keep it a little bit more visible. There we go. And you'll see exactly what's going on. Now the frame gets put in here. Now this is way too fast and probably not really super usable. So what I'm going to do is I'm just going to go back into that driver, and you can see the hashtag is gone. And basically when you type a hashtag and you start typing after that, the hashtag is to indicate, or the pound sign or whatever you want to call it, that whatever you're typing has to be turned into a driver. And you see the moment this is turned purple, now we know this is a driver, so it's going to grab any values in here that we type and use them as a driver. So if I just divide this by 100, you'll see now this is 0.01. And we actually get movement, but this movement is independent of the length of your scene. So if I were to change those keyframes back to what we had before, sure, it won't start from 0 because it's using frame 1001 to begin with. But as we sort of move over this, we can see it update, and all of this stuff, doesn't matter which keyframes you're using, this thing is just going to keep moving, and you can try stuff out without having to change anything in your scene. I really like that because it just helps with prototyping things and trying new things out. And you can just put any sort of modifier on there that you want. So if we divide it by 25, it'll be quicker. And let's say we want this to change as well. So what we could even do is, and actually let's remove this one for now. Hit Alt-G to reset this. We could do the same thing with the rotation, for example. So hashtag frame. And you'll see this rotates incredibly fast. Now, the reason for this is it's not going to give you 1 degree on frame 1. It's actually going to give you 1 radian. So we have to divide this by quite a bit to get this to move away normally, but we could move this over. All the other parameters stay editable of this this empty here. And the cool thing is we can just animate it, move it around, do all kinds of stuff with it, and it will just keep rotating endlessly until the end, it reaches the end of the keyframes and then just resets. So this is a really quick way just to try stuff out. You could put it in scale, rotation, location. You could do anything. You could even have one that is a minus. So if I put in hashtag minus frame, for example, and divide that by 100, now it's going to twist in a negative, like on a negative axis in the z-axis, and we can get all kinds of free rotation, and we can combine these. So let's move this one up as well. And now you can see we've got our texture basically animating without putting any keyframes in, and it doesn't matter. We can change the end to 900 and it's just going to keep going. Now, obviously, depending on where the object is compared to the plane itself, the texture might change a little bit in speed because it's further away. But still, that being said, it's good to be able to prototype this. And if I go back in I can very easily just go back to my modifier or back to my texture, change this around, and the animation will still stay put. So I use this quite a bit, for example, when I'm animating forces in a particle system, which we'll get to later as well, or just when I need something to keep turning really quickly and easily. So this just gives you a very quick idea of how to do this. And as you can see, we've done multiple values, and it doesn't really take a lot of time. So that said, let's look at a second way to, I guess, automate animation of keyframes. So let's talk about keyframe modifiers. And to do that, I'll just grab Suzanne. I'm going to set my length to be 100 frames of my scene, and I'm going to add in a graph editor here. Now, what I'm going to do is I'm just going to set a single keyframe on the location. So we've got 3 keyframes to work with, an X, a Y, and a Z. In the previous example, we saw how we could use a driver to maybe push Suzanne into one direction. Now, what might be more interesting is to use keyframe modifiers for this. And I'm just going to turn off the X and Z location real quick. And the cool thing about keyframe modifiers is they give you sort of a similar way of working where you can automate some animation, but you get a little bit more control than doing it with a driver. So if you hit the N key, the panel opens up. You'll have a little modifiers tab here, and you can add new keyframe modifiers in as you see fit. So I'm just going to make the UI a little bit bigger here so we can see what we're doing. In this case, we just have our Y location, and let's say after 30 frames or 25 frames rather, I want to have her move about 2 units out. I'm going to add in an extra keyframe. There we go. And now what we could do is if we play this, you'll see our 100 frames here. She's just going to stop. But let's say I want to have her move, keep on moving towards whatever direction I was pointing her in. Now, one of the keyframe modifiers I use quite a lot are the cycles. Now, it's funny because obviously we've got a renderer called cycles and we've got modifiers on a mesh. So this nomenclature is pretty hilarious that it kind of repeats itself here. But the idea of the cycles modifier is that it loops your animation. And it's just going to grab the very first and last keyframe and loop it in different ways. So I'm going to move this over 25 frames. So now our keys are over here and you can see exactly what's going on. We have our 2 keyframes in here, and there's being repeated over and over and over again. Now the cycles modifier here has a couple of different ways to set it up. So you've got a before and after, and really all this is controlling is the behavior before the first keyframe and the behavior after the last keyframe. So if we set this to no cycles, for example, it's going to start doing nothing and then it's going to start repeating. Now, the one that I tend to use quite a bit is the repeat with offset, because what this is going to do is it's going to keep going in the same direction that your last 2 keyframes sort of set up. So for example, if we were to go to frame, let's say 75 here, and we bring her back and add in one to the location, and actually let's just add a single keyframe in here, you'll see that it sort of repeats it and does the same thing, and we'll keep moving her up and up and up. So let me add in 100 more keyframes here. You can see exactly what's going on. If we set it to repeat with offset before, it's going to grab your entire animation, do the same thing, and just keep offsetting it. Now, there's a lot of fun to be had here. Again, we could do the same thing here and repeat it mirrored, and now it's going to go forwards and then repeat the animation, but repeat it backwards. So this is just one way of modifying all kinds of animation. Now, generally, you could do all kinds of crazy things with it and really get into it. Some of the stuff that might be important to note is things like restrict frame range and use influence, but we'll talk about those on one of the other tracks when we have some more of these modifiers on. Now you can layer these as much as you want, so let's talk about that next. So I'm going to turn off the Y location for now, and I'm going to turn off the cycles modifier here as well, which means none of these modifications are going to be used. It's just going to stick to the regular keyframes. So let's look at the X location. And let me throw out the Y location keyframes here for a second. So let's grab these extra ones, delete them. And in the final, I guess the final example, you'll have all of these set up so you can turn them on and off. It's just for now, we're going to use different tracks to animate them. So now we've got animation on the X axis. And we've just got one single keyframe in the middle. Now, what if we want some kind of randomized animation, but we, again, don't want to keyframe a whole bunch of steps and do anything like that? What we can do is add something like a noise modifier on the single keyframe. And what that's going to do is just going to add a little bit of noise in. Now, it's got a whole bunch of controls as well. So we can scale it, which means it's going to scale in time. So it's going to become a little bit slower, or we could push up the strength. And that's going to really mess with our distance in which Suzanne is moving. And the cool thing is you can offset this any way you want. You can change the phase. So you can have this on multiple different objects with a different phase, and they're all going to move in a similar fashion, but slightly differently, because the noise, I guess, phase is similar to a seed, where it's going to be the same idea, but again, slightly offset. And then the depth is a cool one because you can add more sort of sub-steps. So you can see how erratically this is moving. And the more depth you give it, the more sort of sub-steps you have, and the more erratically it will start moving. Now, this is a good one to maybe talk about the restrict frame range. I'm going to set this back to 100 frames, so we just have a short animation. Let's say we want to have her kind of move around, and let's play with the phase a little bit until we get something that jumps around. So now you can see every time the animation loops, it jumps. But let's say we want to have this to be more of a smooth transition where we don't really notice the jump as much. That's where this restrict frame range comes in. Now, by default, when you enable it, everything is set to 0. So nothing's going to happen, because basically what you're telling this keyframe modifier is that this modifier can be used from frame 0 to frame 0, and there's no fading in or out. So what we want to do is we want to set this to 100. So now we've mapped it to the end of our scene, and we want our fade maybe at the start to be 25 frames and at the end to be 25 frames as well. And now you'll see this effect sort of fades in and out, and we get a perfect loop. And this really is the power of keyframe modifiers, because you can get all kinds of randomized animation in and really add to it. Now, the cool thing about these is we can layer them, and the next one I want to talk about real quick is the stepped interpolation. And what this is going to do is it's going to give you like this, I guess, low keyframe or lower frame effect, and the step size basically defines how many frames each step is going to be. So if we set this to 5, our FPS is 30, so now we're going to get a 6 FPS sort of effect, and we can add these together and we can do all kinds of stuff. And one thing I forgot to mention about the noise before we add this stepped one here is there's 2 different types to blend. We can either replace or we can add it to the original keyframe, so now it's only going to move in one direction, or subtract it, so it's going to move in the other direction, or we can multiply it by what we had. But because our keyframe is at value 0 here at the x-axis, you can multiply anything by 0, it's going to stay 0. If we set this to 1, for example, now it's going to multiply 1 by the noise. If we set this to 2, you'll see the multiplication will become more extreme because our starting keyframe is a lot further out. So let's set this back to 0. There we go. And again, I'm just going to set this to replace. That way the noise is completely going to take over and just start from the 0 point here. Now we can change this, and actually let me turn it on first, and you can see you could offset this. It doesn't have to like match the keyframes, and you can tell it to use start and end frames as well. So this is somewhat similar to the restrict frame range, only again we could sort of mess with this. And let's say we only want our stepping effect to be between frame 35 and 65. We can set this to 35, you can set this to 65, and now you can see the stepping will only take over from a certain point, and we can have it, and the rest of it be smooth outside of that. So this is really great. In this example, maybe it doesn't look very cool, but it just gives you an idea of what's possible with these. And the same with influence as well, is you could turn down the influence. So you can see, you can kind of get the effect sort of going and add a little bit of weirdness into your noise as well. And again, all of this stuff, you could just keep adding on. For example, if we can add a limits in here, and obviously what I'm going to show you now is we could do the same thing, set it up in the noise by setting it by to additive, but let's say we want this animation never to go under 0. What we could do is we could limit the minimum y to 0, and now you'll see it's just going to cut off my curve. Now, if we set the x to 0, we're going to do this in the other direction past our keyframe, but these two are really, really useful because if we set this to 1, now we know she's never going to move past 1 unit. And you can see that working exactly. If I turn off the stepped here and bring up the, not the scale, but the strength of the noise, you can see it's actually going to clip that. The moment I turn off the limits, you'll see it's really extreme, but with the noise set up like this, she's only going to move in between the values that we've set it up with the limits here. And again, you can turn this influence down a little bit just to get some more weirdness to your animation. So at this point, you might be thinking, well, what is this actually useful for? Well, let's say you've got something like a plane flying through clouds. What you could do is you could put a noise modifier on the rotation of one of the flaps on the wings, so it flaps a little bit in the wind, and you could do it for all kinds of objects. And that's just a very simple example, but it just goes to show you how powerful these are. Now, there's one last one I want to show you real quick. And again, we're just going to turn all of these off so Suzanne stays in the middle. Now let's go to our Z location. And generally, one of the last ones I use as well is the built-in function. And this can just generate a sine wave or other waves that you could use for your animation. And again, if I turn down the phase here, this is just going to give us a very smooth up and down movement. And you can do whatever you want. Again, the restrict frame range and use influence. So cool thing about this is this gives you a sine wave that goes on endlessly, so you could use it to automate any kind of animation as well. And I guess that's just a very quick overview of keyframe modifiers, but I have to do a lot of looping in my work, so it's really handy to know, especially with the first thing that I showed you, that you could easily loop things without having to do all kinds of keyframing, or in our case, let's turn this back off. If we go back to our y-axis, we insert the single keyframe again. Let's say we want her to start from here at the start of our animation. If we were going to use a driver, then it's going to use the first frame or division of the first frame, and you don't really have a lot of control. You could add a certain number to it and try to offset it. But this way, if we just want her to move a certain speed, we could use 10 or 11 keyframes as the next one. Maybe set this to 1.1. Insert a single keyframe, and again, add these cycles modifiers to repeat with offset. And now we've got a very simple speed control. If we bring this in, actually, let me just select the last keyframe here. As we bring this in, the speed increases. As we push this out, the speed decreases. And we've got control over where exactly Suzanne starts at the start of the scene or the start of the animation. So again, just recapping that, these are really powerful little tools that you can use to control your animation in a multitude of ways. And if we turn all of them on, all of these stack together, so you can see as I turn all of them on, she's moving up and down, all kinds of crazy stuff is happening. But the fun thing is this is all controllable and it's all procedural, so you can change it at any time. And yeah, I hope that gives you a bit of an overview of keyframe modifiers. They're incredibly powerful if used for certain situations, and they save you a lot of time by not having to keyframe anything. If you really want to use this as a basis for keyframe animation, you could always bake the animation down and then you get all the keyframes and you can mess with them afterwards. But for now, let's just leave it at this and move on to the next chapter. So now that we've seen how to animate some basic stuff, let's see how I can actually use this to create sort of more of a practical example. So let me just create a queue, subdivide it a whole bunch of times, and throw a cast modifier on there. And again, I'm going to use a displace modifier to show this idea. But the idea is to loop these animations that we can do within modifiers. So in the first part, we saw how to set this up. And now let's have a look at how we can actually loop this. And this is more of a proof of concept. I use it a lot in my work, and if it's not useful for you, then, well, it's too bad. But at the same time, it's good to know that with a little bit of out of the box thinking, you can actually create some really interesting stuff. So what we're going to do is set this up with an empty. I'm going to call this roll.displace. Roll rather. Yep. Let's call this mesh.displace. There we go. Now, to set this up, all we need to do is select the control object. And now as we move it around, this will turn around. Now, the easiest way to loop anything really is just to set this up in a way where the first keyframe is, let's say, at 0 degrees, and then the keyframe after the last keyframe is at 360 degrees. And now if we play this, so let me switch to the timeline here. There we go. Now this is just a looping animation. Now this is kind of boring because I want this to move around, and I want the displace to be a little bit more than just turning around, because honestly we could just animate the object and we would get the same effect, which isn't really very useful. So I'm going to select this empty and delete these keyframes, clear them rather. And what I'm going to do is I'm going to create a curve, and just a circle is fine. Scale it up a little bit. And I'm going to use a controller to move this, I guess, move this controller, bad naming scheme, but there you go. But I want this controller to move along the curve, because a curve is obviously circular and it meets at the same places. So if we move this all along, our animation will actually loop. So let's do that. With our control object selected, let's go to our constraints, add a follow path constraint, and let's select the Bezier circle. And now you'll see as I animate this position from 0 to 100, it will actually move along the curve, and our animation, or rather our texture projection, will change, which is really cool and fun. But if I set this to 0, insert a keyframe here, and again, one frame after the last frame, set this offset to 100, now I've got a perfectly looping animation. Now you can see it looks kind of okay, but we still want a little bit more. And this is really where the fun starts. If we use follow curve, you'll see again we get a spinning sort of texture, and that's not necessarily what we want. But what we could do in this case is also animate this object itself. So let's see what happens when we animate this on the Z-axis. It might be a little bit extreme, but I'll insert a single keyframe, and then again go to the very last keyframe and one more. Maybe 360 degrees, throw that in there. And now you can see you've got an animation that loops perfectly. Now we could push this even further, because we could also animate the curve itself. So let's have this one spin in a negative direction on the y-axis. And now you can see you've got a really kind of interesting looping animation, and all of this is still procedural, so we could still go in, change the size of this, and do all kinds of stuff with it, and really have this as a basis for other things. So I really like doing this kind of thing just because, you know, it's fun, and you can do some really cool stuff, and you're not limited to just one axis. If we throw this over on the x-axis as well, for example, and let's do this in a different direction. Really just down to experimentation. And now let's say we want this to turn twice as fast on the x-axis that we want to do in the z-axis. We can bring together some of those techniques that we saw before. We could either put minus 720 degrees in here, or what we could do is on frame 151 that are minus 360. Oh, wrong one. There we go. We're going to clear that last one. And actually, I meant to just clear the single keyframe, or rather delete the single keyframe. My bad. There we go. And if we now go to our curve editor, we can grab this track, which will be the X rotation. We can hit the N key for our modifiers panel, and we can add that cycles modifier and set it to repeat with offset. And now you'll see it'll repeat perfectly, and we can adjust the speed of this. So again, this is where these come in. Honestly, I would have probably just typed in minus 720 degrees, but now at least if we set this up for all of them, if we could click this little button over here, we can copy these and we can paste them on the different tracks. We could do the same thing for the path. Now, for example, what I could do is just change the N to 600, and the animation will loop perfectly and repeat itself twice because we've set this up with these keyframe modifiers. So this gives you a bit more of a practical example of how to combine this stuff. And again, this is all fun. Now, obviously, we can paste it on this one as well. So it completely loops perfectly. There we go. And now we've got this wild little thing going crazy. And again, it's just having fun. Let's call this texture displace. And especially when I'm animating all these little elements, what I'm going to do is just set this up this way, and then I can start experimenting. So I usually don't really know where my look is coming from. Even with animation, I just know I want to try different things. So again, depending on the animation that we're using, or rather the texture that we're using, we get these different animations, and you can very easily just copy this over. Now we got to reset this. There we go. So just by selecting this controller and hitting Alt-G, we reset it. And for this one, we could use a different texture and just maybe change up the intensity or the size, or we'll use a completely different texture altogether. And there we go, and we get a completely different look. Again, if we were to change some of the values of this, so this one, if we look at the value here in the F curve, you can see that this one is at 360 degrees. We could maybe put this at minus 360. And again, because we've got this all set up, this is now giving us a completely different animation. We could do the same thing by clicking this one, setting it minus 360. And maybe we could put this at 601 because our animation is now 600 frames. We get a slightly slower animation. And also, depending on the size of your texture, the animation will be slightly slower as well. So you can see we get two completely different things, but we had to do very little setup for the second one. And you could create as many of these as you want and go completely crazy with them. So yeah. And again, just by changing different types or different textures, you can get really compelling animations without having to do anything. And they loop perfectly, so they're useful for all kinds of stuff. I could play with these forever. So let's set this back to something we were using before. I think it was the Brave. There we go. Make this a little bit smaller again. This is just to give you an idea of all the options. So yeah, with that said, let's move on to the next chapter. So in this section, let's actually try to build something that we could animate procedurally and have some fun with. So I'm just going to start off with a plane, and what we're going to do is we're going to try and build a rolling wave in a procedural fashion. So I'm just going to grab this and duplicate this a few times, just so we have a base mesh and merge all this stuff together. There we go. And now we could subdivide this a whole bunch of times, just so we have something to start working with. So the idea is just to have a rolling wave going from left to right. And I'm sure you might think, why not just use something like Mantissa? Well, sometimes you just need something that's simple to control. And while Mantissa is great, simulating can take quite some time, and you'll see in setting this up, we can actually do this quite quickly and have a lot of fun while doing so, which is also very important, obviously. So let's start with the basics. Again, we're going to bring in our old friend, the vertex weight edit, and add in an empty mask here and set it up so we have a gradient in our mesh. Grab a mask, create a new texture, and let's call this wave base. And for this, we're going to use a blend texture. And just to preview what's going on, again, I'm going to throw in a displace because we're going to use an object to control this so we can actually see what we're doing, and set this to mask. And actually, rather than mask, I might call this wave just for consistency. And we'll set this to wave and wave. There we go. So now let's add in an empty object. And this is going to be our wave controller. So I'm going to call this control.wave. And we're going to call the plane mesh.ocean. Why not? There we go. So let's grab this. And let's make sure our vertex weight is being controlled by an object. And we're going to do that. And it's going to stay the same, obviously, because the object is in the same place. And as we move it around now, you'll see we've got something moving from left to right. Now, what I want to do is actually make this one peak. So we're going to go into our texture, go into the colors, and in the color ramp, we're just going to set it up to be a linear color ramp from left to right. Now, You could, if you wanted to, sort of push this in one direction or push this in the other direction. But the thing is, we're actually going to use a different setup to shape the wave a little bit more rather than using this one. So I want to avoid having that in there for now. Now, we could change this to maybe something like ease, so we get a little bit of a nicer fall off. And I'm going to set this to smooth shading as well, just so we have something a bit better to work with. And let's say that's the start of our wave. Now, it doesn't really look like much of a wave yet, but that's okay, because the second part of this is that we're actually going to shape this in an interesting way. And the way I'm going to do this, and I want this wave, maybe let's just leave it at 1 unit. I don't want it to be too high. I just want it to give the idea of a wave. And if I just go into front view, we can't really see our texture, or rather our mesh over here, but we need to figure out a way to shape this. So what I'm going to do is I'm going to create a lattice. There we go. And we're going to use this lattice to shape the wave as it moves along. Now, what we need to do, I know this is one, actually, I know this is 1 unit high, so I'm going to move the lattice up. There we go. And you need to scale this at object level to fit it first. Oh, there we go. And then before you do any manipulations, you just kind of make sure that within object level scaling, this entire thing fits within the lattice. So scale this out a little bit more, maybe something like this, and just up a little bit. That way we have a bit more space to play with. So now that that's set up, we can go back to our ocean mesh and we can add in a lattice modifier. There we go. And we can grab the lattice that we've just created. Now I'm going to call this lat.wave. And the way a lattice works is basically whenever you put a lattice modifier on the mesh that you want to manipulate, you can then use the lattice to reshape it in any way you want. And the cool thing about the lattice is you can define the amount of points that you want going up or down. And now, because this modifier is already set up, what we can do, let's see if we can't somehow see the final result a little bit better. There we go. So now we can actually see our mesh as well. Now, if we go to edit mode on the lattice, we can now grab some of these parts, and I'm setting this to my front view and just dragging along these points. So I'm grabbing both sides. And as you can see, I can start shaping this mesh in a way that I want this wave to kind of give it a bit of more of a wave shape. And just by grabbing these points, you can really manipulate the way this looks. And I'm going to move this one on the x-axis. And again, we're just looking for a basic shape. Like most of the examples in this tutorial or training series, I'm just showing you the basics so you can go in and fine tune wherever you want to. So maybe something like this, going to look pretty good. There we go. It's a very basic wave shape, but it works. And now the cool thing is, if we parent this lattice to our wave controller, we can now, see it's in there, we can now actually move this around and the wave will come with it. Now we want to have a little bit more variation in this, obviously, because it doesn't, it looks okay, but we want it to be a bit more, I guess, a bit more dynamic as well. So because we've set this up with the vertex group, what we can do is within our displace, we can either throw in a texture. This is probably the simplest way to do it. Let's see, we're going to call this wave breaks. I'm going to turn off the color ramp. I'm going to set this to something like distorted noise, for example. And I'm really going to crank up the brightness and the contrast, or actually bring the contrast down a little bit. And you can see just by doing that, we get a bit more of a wavy shape. Now the cool thing is, because this is based on because the displace is actually being projected based on the object location, when we move this wave controller around, I'll move it in the right direction, you'll actually see the wave sort of breaking up a little bit. And that's kind of where the fun starts, because we can now just add in a subdivision surface just to get a little bit more subdivided and make it look a little bit better. And if you wanted to, you could get super advanced with this. And in the lattice, you could add maybe more subdivisions. And let's see, I actually don't want them in U, but I want them in V. And you could grab one and push it up. Go, maybe bring this one, push it down a little bit. And now you've got a wave that could even change shape, as we can have shape keys within the lattice itself. So if we grab a shape key here called basis and have another key, grab this part, maybe move this back, maybe move this one up a little bit, and maybe move this one up a little bit as well. There we go. Now we could even have the wave change shape as it moves along. So let's set that up. Let's grab our wave controller, move it over on the x-axis. And let's set a keyframe on the x-axis as well. So I'm just going to insert a single keyframe, bring up a timeline here. There we go. And at frame, let's say frame 300, let's bring this up towards the end. Another keyframe. And what we want to do on the lattice as well, we want to hit I to set a keyframe here, and then set this to 1 at the end. There we go, and hit I again. And now you can see as we play this, and let me just set the playback to frame dropping, we can actually have a rolling wave that we've set up completely procedurally, and you can see it changes shape over time. You have as many of these shape keys as you want, but I want to keep this fairly simple so it stays somewhat performant. If I turn off the subdivision surface, we'll get pretty much a real-time visualization. You can see this works quite well. Now the final step to make this look a little bit more convincing is to actually add an ocean modifier. There we go. And rather than setting this to generate, we're just going to set it to displace. And we're going to have to fiddle with the settings a little bit. Let's bring down the scale maybe, and the spatial size, and then maybe the size itself as well. And bring that up. And the more subdivisions we'll have, the better this will look. So let's crank up the resolution here to maybe something like 15. And now for the final thing we want to do is see what happens. There we go. We've got the scale here. And as we saw before, what we could do is just type in #frame, divided by something like 50. Let's see how that looks. And now we've got a completely procedural wave set up. And of course, this isn't perfect. Like I said, this is a very, very basic setup, but this is just to show you that you don't always have to resort to simulating things or doing other things. If you just need a very simple animation and you need some control over how this wave looks, this will work just fine. And yeah, it's a lot of fun. It's very flexible. It's very extensible. You could always add more stuff into this. And we've added shape keys in now, so I'm not going to mess too much with the base shape. You could control this in as many ways as you need it to, and it will look fine and it will run pretty quick. And again, if you want more detail, all you need to do is just add in a little bit more viewport subdivisions and render subdivisions, up the resolution here, and you'll get a lot more resolution. It'll be a little bit slower, but it'll still work just fine. And to keep things quick, you could always just set it to 0 in the viewport so you can look at it near real time and not have to worry about it. So this is a very, very quick way to, again, use modifiers for procedural animation. And you can see it didn't take me very long to set this up at all, and it looks pretty decent. Again, if I would use this as a final thing, I would probably go in and tweak it a little bit more, maybe add in a little bit more details, add a little bit more animation to the lattice and things like that. But for quick setup, this is quite nice and still quite fast. So I hope you enjoyed this chapter, and let's move on to the next one. So in this section, we're not only going to talk about using cloth sims for animation, but actually how we can optimize using some of these and some cool tips and tricks. So I'm going to start off with a simple example, and really all we're going to do is we want to create something like a flagpole. This is kind of a classic example of a cloth sim, but nonetheless, it's good to know that we can play around with this. So I'm going to create a plane, rotate it 90 degrees, move it up, and just move it over. Now I'm just setting this up in a way that I can very easily start simulating. There we go, and I'm going to keep these squares and just push up the subdivisions. There we go. And let's push up the cloth object as well. And I'm going to create a vertex group where I'm going to grab this vertex and this vertex. I'm going to pin these, which means they'll be able to stay in place on our flagpole. And again, this is just a very basic example, but it's just to show you how you can control some of this stuff. So I've assigned these, called it pin, and now let's add in a cloth modifier. So by default, because of the way we've set up our scene, if I hit play, and let me bring up my timeline here. If I hit play, you'll see by the blue color here, it has simulated some, but nothing's happening because we turned off our gravity. So this particular example, I'm going to turn gravity back on, and now you can see by default, the cloth just falls down. Now, what we want to do is a few things. First of all, let's start with some of the settings over here. Actually, no, let's move on and start with the shape settings first. So what I'm going to do is set the pin group. And now if we start simulating, you'll see it's going to pin those two vertices. But we want the cloth to interact both with itself and with the flagpole. So what we're going to need to do is actually set that up. So on the flagpole, we're going to add a collision. And on the cloth itself, we're actually going to turn on collisions. So object collisions are turned on by default. So now you'll see it does interact with the flagpole. Now you can immediately see some issue with it where the pinned cloth is stuck in and we're seeing some weirdness. So I'm going to move the flagpole over ever so slightly just so it's not stuck to it. We can always move it back a little bit if we need to. But now you'll see it looks a little bit more natural. I'm going to shade the cloth smooth as well. But what I also want to set up is that it self collides. And that just basically means now the cloth will collide with itself and it won't actually intersect all that much. It's going to look slightly better. Now, I want this cloth to wave as well. So what we're going to need to do is throw in a force field. Let's throw in a wind force field and let's have it come in from the left. So turn that 90 degrees. I'm going to move this over just to visualize it a little bit better. It doesn't really matter where it is in the scene because it's going to be blowing in one direction. So you can see by default, this doesn't really change anything. Really going to push the strength up quite a bit. We could do this interactively until we see the flag being affected by it. And you see that towards the end there, the flag actually stops simulating. So what we need to do is, let's say if we set our scene to 600 frames, you can see it stops after a while. So we're going to have to go into our cache over here and actually set it to be 600 frames. So now it's just going to keep simulating. Now with this setup, this is a very basic scene, but it just goes to show you, okay, we've got a nice little flag animation, and I'm going to maybe turn up strength a little bit more even. I really want it to push out. Come on, you can do it. And the main issue is that the flag just seems a little bit too heavy. So whenever I'm doing cloth sims myself, I tend to turn down a lot of these settings. So the tension and the compression in the stiffness settings really, let's say we set these down to 1, for example. Now we're going to get cloth that's a little bit more active, a little bit more crazy. And you can mess with these. If you want to go very extreme, you can turn these settings down really low and you'll get some very interesting results. But for now, this looks fine. We've got a nice little flag waving in the wind, and that's kind of what I wanted to achieve. So with that done, let's actually bake this down. And we'll give it a second to bake here. There we go. And I'm going to save the scene as well. All this results. There we go. And really, what I want to do is talk more about caching this out rather than the cloth sim itself. So, cloth sim is really cool, but let's say you want to reuse this in a different animation, or you want to loop it or do something like that. What are your options? Right now, this is just cached in memory, so it's in our Blender file internally, but we can't really do anything else with it. So what I want to do is actually want to export this and get this out to a file so we can read it, put it on multiple objects, maybe offset it and do something like that. So to do this, we're going to have to enable an add-on. And if I just type in PC2, you'll see I've got an add-on enabled that's called Export Point Cache Format. There's another one called MDD. You could do it with that format as well. I'm just used to using this one. I know it works quite well. And if you enable it, basically what's going to happen is in our settings, in our file menu under Export, we're now going to get the point cache option. Now, what's the difference between something like Alembic or Universal Scene Description? Basically, what point cache is good for, it's sort of a precursor to those, I guess, to those technologies where it will export the, I guess, vertices, the animation of the vertices in an object that doesn't have any changing topology. So the moment your amount of polygons changes or your vertex indices change, point cache won't actually be very useful. You're better off using Alembic or something like that. But I want to use point cache just because it's quite quick and it works quite well. So let's go to Export Point Cache and let's just call this flag. I'm going to make sure to export it to frame 600. You could convert it to Y up. This is mainly meant for other applications, but I'm just going to leave it at this. Set the start and end frame, make sure they're correct, and let's export the point cache. You'll see that goes fairly quick. Now, to get this to work, I'm going to duplicate this plane. I'm going to turn off the original cloth simulation, and I'm going to delete it on this plane as well. Now you can see there's nothing going on. It's just the original plane. Now, the reason I do this is I just want to make sure that I'm using the same base object with the same number of vertices that have the same indices and all that kind of thing. And we just need to make sure that we start from the same base object, otherwise the point cache will freak out. Now, I'll show you what happens when it freaks out in just a minute, or when things don't work and why they don't work. Actually, let's do that first so you get an idea of what's going on. So we had a plane and go. And I think I subdivided this. Actually, no, I didn't. Let's see, if I do this, if I subdivide it in this direction first and then that direction after, maybe the indices will be different. There we go. And let's just look at both. So first, to actually add this, I'm going to add the mesh cache, throw in the point cache, and just grab this file. And now you'll see it just plays back as if it was the cloth simulation and we didn't really have to do anything for it. The main advantage now is that we have a whole bunch of a whole bunch of parameters we could animate. Now for this one, I think I subdivided this one differently. We'll see if it works. Maybe it will, maybe it won't. Again, let's select that one. And here you can see what I mean. If I turn off the other plane, because the polygons are in a different order, we'll get sort of this broken animation because they're being calculated in a different way. So this is definitely something to keep in mind when you're using this kind of thing, that you need to keep this, keep the base mesh the same and make sure it's been generated the same way, or you just make a copy of the original mesh and then import it into a different scene. So that was really just to illustrate, again, you know, if you want this kind of effect, it's a cool sort of broken mesh effect. We can go crazy if we wanted to and throw a wireframe on there, and maybe this looks like something a bit more interesting, but for now this isn't really what we want, so I'm just going to throw it away, just to illustrate that you need to keep an eye on some of these things, and it's a very common problem that might occur. Now I've set this up, I've got my mesh here with the cache. So what is this interesting for? Well, for example, let's duplicate this. And because we've got a duplicate object here, let's say our scene is about 300 frames long. And I want to be able to use the same cache multiple times. And the cool thing is I can offset this. So if I offset this maybe 150 frames and I offset this one maybe 300 frames, I'm going to do minus 300, we could use the same cache, but we can use it on multiple objects. Which means we get a different animation on each flag, but we're only pulling from the same cache file. So this is highly optimized. We didn't have to do 10 different cloth sims. We can just do one really, really long one and offset it multiple times within one scene. Now, one final example that's really fun to use is to actually loop this. So let's say we've got these two which are offset, but this one, I actually want this to loop perfectly. Now you can see there's a jump whenever we go back to the scene. But what I could do for this one is, this one starts at minus 300. I'm just going to copy this modifier, and I'm going to have this other one, have that one start at 0, or 1 rather. Was it 0? I don't know what it is by default. I always forget. There we go. Yeah, it starts at 0. So let's set this one to 0. And because the other one is offset 300 frames, you can see you can animate the influence. So in our case, what we want to do is about halfway through the scene, we want to bring this influence down, and maybe towards the end of the scene, we want to animate it up. So basically what's happening is we're blending these two point cache modifiers. And in this case, you don't really see too much intersection. Sometimes you might have to look for a different point to blend these. But basically, if I play the scene back now, you'll see we get a perfectly looping cloth animation. And if you want to go further, or one step further, you could even export this again as a point cache and then bring it into different scenes. And it doesn't matter how many frames you offset it, you know it's going to loop perfectly. So this just goes to show how powerful caching is. And we're going to be doing this with some other stuff as well. It's incredibly important to think about animation as a tool, as well as the same way we did with modifiers. Caching, it makes your life so much easier. You don't have to deal with recaching things or bringing them in. You can just import this object. You can have a library of objects, for example, in your scene or in a library file. Just import maybe a looped flag animation that's 1,000 frames long. And if you have a 400 frame shot, you could duplicate it all over the scene, offset it a couple of times, and you've got an asset that you could reuse, and that's super lightweight. And again, because these are all modifiers, just the same with the cloth, you could add in a subdivision surface if you want it to be a little bit smoother, and add in more modifiers on top if you really wanted to. You could move this flagpole over a little bit, and now it looks like it's actually interacting and stuck around it. So again, yeah, it's all about flexibility. I'm sure we're quite a few number of videos deep in this series now. I'm always looking for ways to just make things as flexible as possible, and animation caching, especially with cloth like this, is one of the more useful things you can do just to save yourself some time and a bit of a headache. So I hope you found this one interesting, and let's move on to the next one. So in this example, let's talk a little bit about caching and using it as more than just a caching tool. And what I mean by this will become clear as we move along, but we're going to try and do something really weird and experimental, and we're going to do this using hair. Just to talk about some of the options that we have when caching. So I'm going to start with a very basic example. Let's grab just a torus, it's fine. And let's slim it down just a little bit. And I just want to have hair emitting from this circle as a very basic example. So what we're going to do is we're going to add in a hair system, and I'm going to bring down the amount of hairs just to keep things rolling a little bit smoother. And to set hair up properly, you want to add in a couple of segments. And there's 3 sections where you need to add in segments: the render section and the viewport display section. And the reason we do this is now if we add in something like a force, generally when I'm using hair for stuff, I'm not actually using a hair simulation. I'm just using it to create sort of weird and wonderful things. So for example, if we move the simulation around now, you'll see that this hair stuff does some really interesting things. And we could very easily, again, loop this. And I'm not only showing you this because it's fun to loop stuff, but it can be useful for all kinds of things, really. So let's see what we can do. And like I said, I want to get kind of crazy with this. And I want to talk a little bit about how to transform this hair into different sort of types of objects. So how to go from a curve to a mesh and that kind of thing, and what the advantages and disadvantages are when using caching to do that, essentially. So we've got 300 frames here. What I'm going to do, I've got a field here. What I'm going to do is give it a size, just so it has a bit more of a predictable shape. Now, when we animate this, the hair does jump around a lot. So maybe let's set this to something like 50. And it's not really meant to be sort of a final animation, but more just to show you what you can do with it. I'm going to duplicate this once, and then I'm going to parent it to the original field. And the reason for this is I want to be able to loop this. So what I'm going to do is I'm going to go into my transforms. And first of all, I'm going to animate this from 0 to 2. And I'm animating it on the x-axis while I meant to animate it on the y-axis. So let's try that again. So insert a single keyframe on 0. And the reason I parented the other force is I parented it 2 units back. So when I now move this 2 units to the front, the second force is in the same position that the first one was. So if we now animate the both of the strengths here as well, I'm going to insert a keyframe for this one, set this one to 0, and again insert a keyframe for this one. Move on to the frame after the last, set the same strength, and again set this one to 0 as well. And because I've set a size, basically this animation will now loop perfectly. And you can see it's kind of creepy and crazy. You could do this with all kinds of forces. You could create almost like a lightning looking effect as well. But I want to talk a little bit more just about how to cache this out and how to do even more interesting things with this. So this is a fun animation. So let's actually look at how to cache this out. For this example, I'm going to be using Alembic. Mainly you'll use Alembic for all kinds of caching, whether it's a character or waterfall or like a water sim or something, or you know, you could even cache out particles and things like that. And we'll focus on those later, but I want to focus on hair first. So when I export this, what we can do is export this as an Alembic. And first I'm going to save my scene just in case. So there we go. That's not the cloth, we want the hair. All right, there we go. And I just want to cache out this torus. Now, when we go to the Alembic export settings, you'll see I'm going to call this hair curves. And I want to only export the selected object. I don't need to export into the other objects in the scene. I'm going to keep all this stuff, it doesn't matter, but I also want to export hair particles. So I can turn off particles and leave on hair, but for this example, it doesn't really matter. And what that's going to do is if I now hit export Alembic, it's going to take a second, but basically what it's going to do, it's going to convert those hairs or those hair strands to animated curves for us. And that gives us a whole new set of options when bringing these back in. So I'm going to turn off all of these objects for now and just bring in that Alembic. So let's go to import Alembic and bring in the hair curves. And now you can see this plays back pretty quick as well, which is nice. This torus I don't need, so I'm just going to delete it. And now we're just left with the curves. And yeah, now because they're curves, we've got all these options that we could use. So for example, we could bring in geometry, so we could extrude it and get sort of strips that look kind of crazy, or we could bevel it and just give them thickness. And again, this might slow down a little bit depending on what you're doing. And you can see it bugs out a tiny bit. So don't worry about that too much, but sometimes you just need to move a frame or whatever to make sure that it resets. But at the same time, like I said, now we've got a whole bunch of options. Now this is kind of cool, but again, they're curves. So I want to be able to use some modifiers on this, like I would with a mesh. So what we can do is now re-export this, for example, and I'm going to reset the bevel here. I'm going to set the offset, maybe 0.1, or not the offset, the extrude rather. And again, this isn't really to create like a final look or anything. It's just to give you an idea that caching can be even more powerful than just, than just caching something out and reusing it. We can use this now to transform this to a mesh. So if I go back to export, and I'm just going to reset my frames to make sure there's no bug in the viewport or in the frames. And I'm just going to export this to Alembic again. And instead of calling this hair curves, I'll call this hair mesh. And again, I'm just going to export the selected ones, make sure that it's, that it's the renderable objects. Now, if you turn this off, for example, then you could have an object select that it isn't set to renderable. And it's good to remember that Alembic will always take the modifier settings and other things that are set at render time. So for example, if you have a subdivision modifier thrown onto something and it's set to more subdivisions in the render settings than it is in the viewport settings, Alembic will actually take the render settings. So that's something to keep in mind as well. But what I want to do is export these curves as a mesh. So if I now export this Alembic, and again, this just takes a second, we can turn this one back off. and we can import the next alembic, and let's grab the hair mesh. And now what you can see is this has turned everything into a mesh. We don't have our curve options anymore. This has now actually become a mesh. That means we can throw more modifiers onto this and go completely crazy with it. So again, you know, you can see these are just mesh strips that we could use. So for example, we could throw on something like a solidify to give them a bit of thickness and maybe smooth them out a little bit. And obviously, depending on the amount of polygons you'll have, this will significantly slow down. I don't want to repeat too many of the smoothness, but just a little bit. We get kind of smooth curves. And if we want to get really crazy and creepy with it, what we could do now is add in something like a displace modifier. And just maybe take down the strength, add in any old let's just leave the distorted noise. And now you can see we've got that same animation, but we've really upped the look even more by using the distorted noise. And it's all looped because of the way we set it up. So now we have this really crazy, creepy asset we could use for all kinds of things. Now, obviously, there's a lot of jumping around. So if you don't want that, you might have to tweak the original settings for the hair. But this goes to show you that there's really a lot you can do with these animation caches. We went from hair to curves to a mesh, and each step of the way just gives us completely different options. Like we could really overdo the mesh here. We could smooth this out again even more afterwards. We could throw on a subsurf if we wanted to, which I'll try, but this will probably be quite slow because it's not very optimal geometry. It's not too bad. But there you go. Now it's subsurfed, and again, this just changes the game because now we could use different things. Different shading settings because it's a mesh, or like I said, we've transformed this now to multiple different formats. So whatever format we need it in, we could actually use Alembic to, change it over wherever we need to whatever we need it to be, rather. And I think that's something that doesn't get mentioned a lot about caches. And the cool thing is, it's just a file, so we can re-import this file anywhere we want and reuse it anywhere we want. So like I said in the cloth caching example, you could have a library with stuff that you've pre-created and things that you use and everything. So yeah, again, this is just a case of showing you how powerful this caching stuff is and why you might want to think about it differently when using it in the future. So I hope this gives you a cool kind of overview of the power of Alembic and how to maybe abuse it for other stuff that you might not have thought about before. And with that said, let's move on to the next chapter and look at how we can use it to cache out particles in different ways as well. So yeah, let's do it. So let's talk about caching out particles. Once again, in my line of work, I need to do a lot of looping, and caching particles is very useful for that. So let's only not just talk about that, but how you can actually get more information from caching out particles than you might think. So to do this, let's set up a very simple particle simulation. And I'll make sure I have another timeline going here. There we go. And I'm going to set my timeline to 450 frames, and why will become clear in just a second. But basically, I want to loop a 300 frame particle animation. Let's say that's the case. And the way we're going to do this is we need to make sure that we have the amount of time that we need to loop, so from 1 to 300. We also need to extend it further along for the lifespan of the particles. So if I add in a particle system here, and let's do 10,000 particles. I want to have particles start and end at frame 1 and 300 respectively, which means if I give them a lifetime of 150, we'll have 450 frames that we need to cache. Because obviously the ones that get spawned at frame 300 are going to last another 150 frames. So they're going to die at frame 450. And let's just let it run. And there you go. We've got that done. Now, if your particle simulation looks slightly different, that's normal. Again, remember, I turned off gravity at the very beginning of this course, mainly because I'm not always looking to simulate gravity immediately. Most of the time I'm doing sort of crazy effects and that kind of thing, and I only turn it on when I need it, when I really need it. So in this case, let's actually tweak a couple of things before we move on. First, I'm going to set the viewport display to velocity. So this means they're going to be colored according to how quick they are. And I'm just going to change the size to 0.2. They are quite huge. Now, I don't really want them to have any initial velocity, so I'm going to turn that down as well. So now they're just going to spawn. I'm going to do something kind of crazy with them. So let's just add in a turbulence force and the strength. And we could do this interactively. So let's set the strength up and maybe change the size. And again, this is just to show you how some of this stuff all comes together into one sort of unified workflow. So in the physics, I'm going to up the drag and damp just so the particles don't go completely crazy and we get kind of a nice pattern. And because we gave this force field a size, it's going to sort of put the particles in the same position the whole time. And I want them to be a little bit more dynamic. I don't want them to just move in one direction. So again, we can go back to the things we spoke about earlier and type in maybe hashtag frame here, divided by 50, and maybe do the same thing for the rotation. See how that looks. I know we've got a little bit more of a dynamic force moving through it. You can see they swirl up a little bit more and they just look a little bit more interesting. And you could add as many forces as you want to this. This was really just a case of trying to make it look a little bit more interesting in a very quick way. So now that we have this particle simulation, let's look at how to export this. And let's start with the most basic way. And I'm going to start giving some stuff names here because otherwise it might get a little confusing. So this is my force. And this is my emitter. And before we move on, one of the things I want to do obviously is cache out my particle simulation. So under cache, we're just going to hit bake. And this is going to bake them to memory. And there we go. So now that I've got this, I want to export this. And we're going to be using Alembic in this example. And just with our plane selected, all we need to do is go to, and actually let's save this file first just to be on the safe side. Go, and now we can export this. So we want to make sure we're only exporting the selected object because we don't really need the force or anything. And we want to make sure we're exporting particles. So let's call this particles. Can't spell today. There we go. Basic. And make sure we're exporting frame 1 to 450. Export that Alembic. And now we could turn off our plane. We could import that and bring in the Alembic. Grab the particles basic. And I'm just going to have a look. This is our plane. I don't really want this. I just want the particles. Now you'll see the Alembic cache has brought in these particles as vertices. So the cool thing about this is that we can now use this as an instancer object. So if I just create a cube, and I'm going to scale it down just a touch. If I were to parent this cube to our Alembic object, then in the object settings, or object properties rather, of our Alembic, we could use this as an instancer. So if I instance a cube to each one of these verts, now we get our particle system, and we can still throw in any object we want. And any change we make to this cube will actually propagate to the Alembic file. Now, this is where the looping part comes in. If I bring in this Alembic just again, just the same one, and again, I'm going to delete the plane because I don't need it. I'm going to make a copy of this cube. And I'm going to parent it to the second Alembic. And again, we're going to just activate vert instancing on this one. And now we've got the two sort of running through each other. And that's not really what I want. But if I set my end here to 300 frames real quick, and I offset this again, minus 300 frames. So now we're going to start at frame 301 for the second Alembic, for the offset one. And we're going to start at frame 1 for the other one, which means that if we now play this, and we just let it run to the end, it should loop perfectly. Here we go. So now we've just looped a particle system, which is awesome because we can do all kinds of stuff with it. Now, the only drawback that I'm seeing here is obviously I want this to loop a little bit nicer. These particles are sort of just disappearing when they die. Let's say I want to bring out 2 more properties from these particles and want to be able to make sure that they rotate in the direction that they're moving. And also I want to be able to scale them somehow. So what I'm trying to achieve is having them scale up as they're born and then scale down right before they die, just to make the make the loop look a little bit more seamless, rather. And to do that, we're going to have to adopt a slightly different method of bringing these out. We're still going to use Alembic as a cache, but we need to think about how to get those properties out. Now, these are great. I'm going to keep these around because this is just one way to do it. But I'm going to turn on my original plane and my turbulence again and make sure I set my end frame to 450 once more. There we go. And this is our original animation again. Now, I'm going to have to re-simulate this because right now we don't really have anything going on. We don't have any rotation going on, so we're going to need to set that up first. But before I do, I'm actually going to create the object that we're going to instance in the particle system. But we're going to use it slightly differently than we normally would in a particle system, and why will become clear in just a minute. So what I'm going to do is I'm going to create a triangle. So all I've done is create a circle, make sure it's filled, so it's an n-gon. And this is the object that I just created. It's the most basic shape you can have. Obviously, a triangle is the simplest polygon you can have, but with this, we'll be able to, when we export it, have scaling and rotation in our export with the Alembic as well. So I'm going to call this particle.try, just so we know what's going on. And I'm going to go out of local mode here. What I'm going to do with this triangle is I'm going to use a particle instance modifier. And what this does is it's going to grab particle system from whatever object we're using. So in our case, this is emit plane. And you can see there's a whole lot of particles here already. And by default, it's showing us the unborn and the dead particles, and we want to turn that off. And now it's basically as if we've created a particle system with this, with this plane in it as a instancing object. But the reason I'm doing it like this is this becomes one mesh. So that means it becomes something we could actually export as an Alembic. Now, to get this to look correct, I'm going to turn on size here as well. And by default in our particle system, the size is set to 0.05. So let's set this to 0.1 just to visualize this a little bit better. We can even have some randomness in there if we wanted to. And for the final thing we need to do is we're going to turn on rotation. And what we need to do first is delete our bake here in the cache settings. And if we turn on rotation and turn on dynamic, now if we start simulating, you'll see these polygons will actually turn around and they'll have some rotation on them. Now, it doesn't really matter how they're rotated for now. Really, the only reason I'm doing this is to get that information out. So let's bake this again first. This should go fairly quick. There we go. So now that this animation has been baked, I want to add that scaling into it as well. And in Blender's particle system, you're able to use scaling by using a texture. Now, because we've already cached this, you might think it might not be possible to use it, but it actually is. So we can still set this up without having to recache it. So in the textures, what I'm going to do is I'm going to create a new texture called scale. Go into those texture settings, and I'm going to use a blend texture for this. And by default, this isn't really going to give us anything different. It's not really going to do anything because we need to set up the way this is being interpreted by the particle system. If we open up this influence tab, we have a whole bunch of options, but really what I want it to do is just to influence the size. So I'm going to turn off general time. I'm going to turn on size. And what you'll see, because this goes from black to white, is the particles are going to start small and they're going to grow throughout their lifetime, or at least that's what I want them to do, but they're not exactly doing that. So the reason for this is it's actually using generated coordinates on this plane to apply this texture, and that's not really what we want. In the mapping type, there's an extra one, especially for particle systems. And basically, what this does is it's going to create it's going to map the the texture along the edge of the particle, basically. So if we set this to strand particle, now what you'll see, if I just turn the render here to none, so we can only see the triangles, you can see they actually grow as they get older, and when they're at their maximum size is when they die. And the cool thing is, because this is a texture, and we've done this before in the procedural, like in the modifiers part and in other parts of the tutorial so far, if we set this color ramp, now this color ramp basically becomes a control of the size of the particles over their lifetime. If I set this to maybe 0.25, and control click to add in another one, set this to 0.75 and one last one and set this to black. Now we've got particles that grow out as they're born and then sort of get smaller as they die. And this is perfect because this means we can loop things and we won't have particles popping in and out, and will actually look quite nice. Now, this is where all the magic happens. Because we've set this up as a particle instance modifier, this is just one mesh we could export as an alembic. So let's grab this, export it as an alembic, make sure 450 frames. We can leave the hair and particles on, but really now we're just exporting a mesh. So I'm going to call this advanced. Let's actually spell this correctly. Go. Particles advanced, export the alembic. And we can turn everything off once again. And let's import that one. There we go. And now we've got that animation. But the most important part is, and let's use a monkey for this to actually illustrate this a little bit better. If we're looking at the simulation, and we're going to do the same thing we did before, where we're going to parent Suzanne to the particle simulation. This time in the instancing, what we can do is we can use faces, and we can scale them by face size, which means if we look at the monkeys, they'll actually get smaller as they die as well. So now we've not only cached out our particle simulation, actually let's leave her on and just hide her, but we've also brought out rotational and scaling information at the same time. So this becomes even more powerful. And again, we can do exactly the same thing we did before. We can import the alembic a second time. And just in case I hadn't mentioned this yet, the reason I'm importing this a second time and not copying this is because if you copy this object, the animation data will actually stay linked and we can't offset it because we'll offset both of the alembics. So you'll have to bring it in twice. This is just the way Alembic handles data, and it's not really a problem or anything. It's just something to keep in mind. So I'm going to duplicate Suzanne. What I'm going to do is parent her to the second Alembic. And in the Alembic settings, all I'm going to do is bring in the frame offset to -300 because we wanted to loop this for 300 frames. Set the end frame to 300. And again, set the faces. I'm going to turn off display instancer in both of them, so that will hide the original alembic triangles. And again, scale by face size. And if I hide these two Suzannes now, you'll see now we get a perfectly looping particle simulation, which doesn't only have the positional information, but also rotational and scaling information. There you go. Perfect loop, and you could throw any object in here you wanted, and when we're going to talk about shading, you can actually do some extra stuff with shading as well. And this just goes to show caching, while it might seem like a really boring subject, it enables you to do so many extra things once you start thinking outside the box a little bit. I mean, we've seen with the cloth how to loop it, and we've seen with the hair particles how to transform the hair particles into different sort of types of objects, and now we've seen how we can bring out a lot of data from the particle system to an alembic to create a loop or anything else you might think of using this technique. So yeah, I hope this one wasn't too mind-bending. I know it can be a bit quick sometimes, but I just want to show you that all of this stuff is incredibly useful. And again, I love using this because now the alembic is just a file that we can reuse over and over and over again. And you, again, like I mentioned in the previous ones, you could create a library with different movements, different simulations that you can reuse very quickly for different projects if you wanted to. So yeah, with that said, it's once again time to move on to the next one. So in this session, let's actually talk about dynamic paint. Now, to set this up, we're going to keep it fairly simple. but mainly I want to talk about how to set it up properly and some of the gotchas with Dynamic Paint, because it can be a little bit finicky to get it working if you've never used it before. And I just want to go over some of the basics, make sure that this is working. So let me throw in a timeline here. There we go. And for Dynamic Paint, what we need is actually two objects, because the way it works is it allows us to create a vertex group by using one object to paint it in on another object, hence the name Dynamic Paint. Now, let's very quickly just set something up here. I'm going to create a cube. Actually, let's undo that. There we go. And what I want to do is I just want to have it slide over the plane here. And to do that, I'm just going to use a curve. Go, and as we've done before, we're going to set this to poly just to make our life a little bit easier. I'm just going to extrude this out, create sort of a path on the plane. There we go. Select everything, set the spline type back to Bezier, and set the handles back to automatic. And now we've just got a very simple curve that we're going to be able to control our cube here. So to set that up, we're going to go into our constraints, add a follow path constraint. Go, and now we can just animate the cube going in and out. Let's have it follow the curve and use the fixed position. So now we can insert a keyframe at the start and insert one at the end. And really, all I just wanted was something to move across this plane to use for the Dynamic Paint. Now, let's have a look at how to set this up properly. So in the physics tab here, we have a Dynamic Paint physics setup. And when you add it by default, nothing really happens because we need to be able to differentiate between these two objects. And the way this works is the object that you're painting on is called the canvas. So you can see we have a canvas and a brush. We're going to add a canvas to our plane here, and to our cube, we're going to add a brush. So I'm going to click Dynamic Paint, select brush, and add a brush. And really what this is going to do is going to use the mesh volume, as it says here, to paint a vertex group on the plane. Now by default, when we go into weight paint mode, you can see nothing's really happening. And there's really two reasons for that. The first reason is if we go into output, we still have to change our surface type. You can see you can also use vertex colors for this, or displace or waves. Now we're mainly going to focus on the weight and maybe talk about the paint very briefly, because honestly we've been doing a lot of cool stuff with vertex weights, and we want to continue that trend by showing you how to paint them in here. And when we select the surface type and we set it to weight, you can see the vertex group set to DP weight. Now this vertex group doesn't exist, so we'll have to create that first. Weight. And there could be any name you want, but I like to stick with this name. And you can see immediately our cube starts painting a weight onto our plane. So this is really cool. And another thing which we might want to do when it comes to Dynamic Paint is in the settings here, there's cache settings, but they're currently grayed out. And if you want to cache this out to be able to use this for animation, the issue is that it's not being saved anywhere. And unfortunately, this can't cache to memory the same way particles and cloth can. So we'll actually have to save this file before our cache options show up. So let me just hit the save as. Go, and now when we reset, you'll see the cache options open up and we could bake it. So now if we bake this, for example, we actually have a baked animation. We could turn off the cube and the animation would stay the same because it's baked down, and we can reuse it for anything, which is really nice. Now, one thing to note is that we have some options, and to visualize this, let's actually throw on a displace modifier. And I want to displace everything but the weight. So let's say this is like a snow covered surface or whatever. Now with the weight, when we play, you can see we actually get sort of a footprint, for example, of something that went through. Now, kind of the icon of the Dynamic Paint shows you this as well. This is originally sort of what it's meant for. And if we just delete the cache again, so if we delete the bake, Now we can start messing with the, I guess, the fall off of the cube itself. So if we go into the source and we set this to mesh volume and proximity, now you can see you can actually mess with this proximity. I mean, you could even animate it if you really wanted to, but if we just set a little bit of distance, we smooth out that hard edge. And again, we can visualize this by seeing what the weight paint is doing here. Now, one other thing that might be interesting is rather than have this be our mesh volume, you could also have it be a particle system and have that particle system affect the weight as well, which is really cool. Now, the fun thing about this system, I guess, is you could have multiple surfaces being affected. So generally, what you can do is if you want to use this for something like snow or something else similar, but you want to affect the color or the shading, then you can add a second surface and maybe set that one to paint. And now we've got the paint map and the wet map. So this is actually called DP paint map, I believe. Let me just double check. There we go. And in the vertex colors, if we add a DP paint map, and now we go to vertex paint, you'll see this will actually get painted in the blue color. Now, why is this blue? Basically, in the brush, we go into the brush settings. You can see the paint color that it will select. So if we just set this one to 100% white, we go back into the vertex paint. Now it's actually painting it white, which looks pretty cool. So we could even use this for shading, like I said before. Unfortunately, vertex weights aren't able to be used for shading, or at least not in an easy way. There's a weird trick with UVs and stuff, but it's not very reliable. So at least in this case, we can paint a similar mask and then use it for shading as well. Now I'm going to turn this off for now. I'm going to go back to the weight paint, and there's another little option which is kind of fun, and it's called dissolve. So if we turn this on, and let's say we set the time to maybe 90, then you can get a map that actually dissolves, and you could use it for all kinds of cool effects. And this is one of the things I'll talk about in the project files towards the end of this course. I'll show you how to set up a bit more of a complex, I wouldn't really call it complex, but I'll show you how to set up an interesting way to generate some crazy patterns. And we're going to use dynamic paint to do that. And this dissolve feature is definitely a big part of that as well. So yeah, this is a very brief overview of dynamic paint. There's a lot more in here, but honestly, I mostly use these parts in combination with the stuff that I've shown you before. And for procedural modeling, it can be really fun just to have one object affect another. It doesn't have to be an animation, it can be a still as well. So even if you just have two objects maybe intersecting each other and you want parts of the mesh driving the other one of the other objects, then you know you can do it with dynamic paint. And like I said, it could be a still or it could be an animation. It's up to you. Again, you want to give these names and bake them out. I've noticed that if you don't give the caches names between the two different surfaces, it's not going to bake out all of them. It might have some issues. So always make sure, especially if you're using multiple surfaces, that you're giving them different cache names as well. In the paint surface type, you've got a wet map as well. So that's able to dissolve the same way as the vertex weight edit, but you can also do it in the regular one. So there's really so much you can do. The cool thing is for the wet map, yeah, let's say you have particles and you want them to be rain on your surface, then you could use those particles as a wet map to give it like a rainy look or something like that. So the options really are endless. This gives you a good introduction to what dynamic paint can do. And I hope, yeah, I've explained some of the pitfalls a little bit so you can get started with it and have fun with it. All right, and with that said, it's time to move on to the next section. So let's talk about the mirror modifier, but for animation rather than modeling. And once again, to set this up, I'm going to keep it very simple and use the same trick that we've used a couple times now. And just grab a subdivided cube, set this to cast, just so we have a sphere. And now all I'm going to do is displace this. Now with this setup, let's throw in a texture here and maybe just bring it up in size. And the idea is to generate these really kind of weird looking, almost fractal looking meshes that you can play around with interactively and have a look at. So the first thing I'm going to do is I'm actually going to animate this stuff. And again, to animate our displace or our texture in the displace, we're just going to use an empty. And let's type in hashtag -frame 25 or something for a driver, and maybe have it animate on the y-axis as well. And this isn't doing anything yet because we need to set the texture coordinates to be an object, and we're going to grab the empty. Now I'm going to start giving these names because we're going to use more than one empty, and I want to make sure I'm grabbing the right one each time. So rolled up displace. And I'm still having issues with spelling. There we go. Okay, and now let's throw on a mirror modifier to begin with. So the mirror modifier has had some updates since, well, for 2.8 at least. And the cool thing about it is now we've got a few extra options, and one of them is the bisect option. Now what this is going to do is going to grab one side and just throw away the other side and stitch it together. Merge is enabled by default, so that means we get one nice watertight mesh. You can see just by adding this in, we're already getting some really interesting animation. Now I want to really push this even further. So let's see what we can do when we add in another one. And I'm going to call this roll.z mirror. And in each mirror, we can actually add a control object. So in our case, what we're going to do, we copied this one over, and it's not really going to do anything because it's still set to the same thing. But I want to use this to mirror it on the z-axis, but also I want to use this controller to actually define a different point where the mirroring is happening. So now if I bring this up, and we might have to flip this. There we go, so let's flip that over. You can actually see I can expand the object and make it a little bit bigger and make it mirror a little bit more just by bringing up the mirroring point and changing it. And I'm going to grab all of this, bring it all down. Again, this is all interactive, so you can leave it playing while you're messing with it. And that really makes it the most fun thing of all. And I'm going to add in another empty. I'm going to twist that 45 degrees on the y-axis. Y.mirror. And let's go back. Again, copy our mirror, and this time let's grab the y-axis and turn off z and turn on y. And this time I'm not going to turn on the bisect, just so it mirrors in both ways. Now you can see we're already getting a really crazy and funky result. So just by setting up a few helper objects and a couple of modifiers, now we're getting this really interesting sort of almost fractal looking mesh that we could animate, and we can shade and just generally have some fun with. And again, it's all down to having this be interactive. So if I change this now and just start messing with the types here, see if we can get something that looks a little bit crazier. There we go. Maybe mess with the contrast a little bit. And you can see the possibilities really are endless. As we change this around, it really just does some really interesting and cool stuff. We can even mess with the mirrors again, bring it up or down. Even the Z mirror could be rotated, for example. So just by rotating that, we get another extra plane of craziness. And it's all, like I said, I'm kind of repeating myself at this point, it's all interactive. So as we change all of this stuff, the entire thing will stay playing, and you can just have so much fun with it. So the mirror modifier is one of those where it only seems useful for modeling, but it really isn't. You can do so many cool tricks with this, and especially with this bisect option where we actually have the mesh and we only keep one part. If I turn this back off, you'll see it'll become one big mess, but just by turning it on, because we start with only one side, we can actually very easily get more complex effects. For this last one, we can turn off the bisect as well, but then because we've turned it, we don't get an as cool result. So for this one, we could turn it off, and now it looks like we've got this really crazy looking, God knows what. I mean, you don't really have to know what you're making as long as you're having fun making it, right? And again, if we go in and change this, we could change it to anything. And especially for the type of work that I do, like VJ loops and things, I can create so many elements so quickly just to throw in a scene and use for things. And when you start shading this, you'll notice it's a lot of fun to use. And again, we could even bring in a subdivision surface just to smooth it out, or we could add in another one up here if we wanted to. And it's really just up to you what to do. Again, if you're having too many shading artifacts, you could bring in a smooth modifier towards the end just to smooth out the last edges and bits, and it will start slowing down, but that's not the end of the world, you know, it's fine. If we bring this back down to 5, it'll be a bit more real time. But again, it's up to you just to experiment and mess with this. And you can see, once again, simple bunch of modifiers and a really cool result. So, all right, with that said, let's move on to the next one.